Okay, just a few more examples from exercise 13.1, approximation of trig functions when x is small. So you might come across questions like this. Find the limit as x approaches 0 of sine of pi minus x over x. Now what we can do, this is sine of 180 minus x, so that would be in the second quadrant. So I would be changing the way that sine of pi minus x looks. So this would be in the second quadrant where the acute angle is x, because this, remember, you've got theta, 180 minus theta or pi minus theta. Quadrant 3 is pi plus theta or 180 plus theta, and quadrant 4 is 2 pi minus theta or 360 minus theta. So how else can we write sine of pi minus x? So this angle here is pi minus x, okay, so it's in quadrant 2, so it is the same thing as saying the limit as x approaches 0 of sine x. Remember, we write it as the acute angle, and with all stations to central we know that sine is positive in quadrant 2. Okay, so it's the same as asking the limit as x approaches 0 of sine x on x, which is 1. Okay. Now for this question here, find the limit as x approaches 0 of sine x squared over x. Now that can be written as the limit as x approaches 0 of sine of x. Remember, sine squared x means sine of x times sine of x. So it's sine of x on x. The reason I want to write that is that we know the answer to that result, okay? So times, and we still need one more, sorry, the limit as x approaches 0 of sine x. Now I could have just written, I didn't need to write this bit here, the limit as x approaches 0, I could have just written times sine x, okay? But I will leave it like that because you're really doing the limit of this times the limit of this. So I'm just breaking up sine squared x into sine x times sine x. So it's good to pair these two together because we know that that answer there of limit as x approaches 0 of sine x on x is 1 times. Now we can actually just substitute 0 in here. The reason we need this limit is not because we can't do sine 0, it's because we can't do sine 0 divided by 0. So we can actually substitute x is 0 in there, and we know that the sine of 0 is 0. So our answer is 0. Another thing you could do, provided that you are in radians mode, so if you go to your calculator in radians mode, you can substitute a very small value of x, such as substitute x is 0.01. So in your calculator you would do sine of 0.01 times sine of 0.01, which is, you would square that answer over 0.01, and you will find that you get a very small value, that value approaches 0. I think you get 0.00 something. So you can see that that value is getting quite small, so it would approach 0. Okay, this question here, 3e, very similar to this other one up here, but you need to do a sketch. So where is the sine of pi plus x? Now that is quadrant 3. So here's 0. This is pi, that's pi and 2. Okay, so pi plus x means that this little angle in here is x. This acute angle here is x. So we've got all stations to central, and we know that sine is negative in quadrant 3. So this is the same as asking the limit as x approaches 0 of, it will be negative sine x. It's because the sine of pi plus x is the same as negative sine x. What we can do here, we know the result to limit as x approaches 0 of sine x on x. So we can take the negative out the front. So this will be negative 1. Okay. Okay, and just this example here, we need to rewrite the way that this cos of pi on 2 minus x looks. Now this is a complementary result. We know that the cos of 90 minus theta, for example, is the same as sine theta. So for example, that's like cos 60 equals sine 30. For example, if theta was 30, we know that sine 30 is the same as cos 60. So this is this complementary angle result. So we can replace the cos of 90 minus x or pi and 2 minus x with sine of x, okay? over x. So remembering that the cos of pi on 2 minus x is sine of x. Just using this result up here. So this is just limit of, as x approaches 0, of sine x on x, which we know is 1. Okay.